What's the matter, Bobby?
I wish I was better at rock climbing. The last time I tried, there was an incident.
Here at Art Industries, we have a solution for that. We use gecko technology. Have you ever seen one of these climb a wall?
Welcome to Art Industries. Let me show you around. Here at Art Industries, we've developed the gecko glove,
It's small, and it's our most advanced technology yet.
which uses nanotechnology to mimic the behavior of the van der Waals attractive forces in the gecko's foot.
It's like tape, but without the glue.
Van der Waals attractive forces are caused by dipoles in the atoms of the gecko's foot.
It's like a sea of electrons sloshing all over the place.
The strength of the van der Waals attractive force is dependent on the distance from which the gecko's foot is oriented to the wall.
Well, then why doesn't my hand stick to the wall?
Because you haven't unlocked the secret of millions of years of climbing evolution. Let's take a look at this sucker's paw in the SEM. Here's a view of the gecko's foot in the SEM. Here's a closer view of the gecko's setae splitting into spatulas at the very end. This shows the arrangement of the nanostructures on the gecko's foot.
Well, how do you know the gloves are going to be strong enough to hold me to the wall?
There are over 6.5 million setae on the gecko's feet.
We counted.
If all of these setae were attached to the wall at the same time, the area of the gecko's feet could hold up over 133 kilograms of mass. Now, 1 square centimeter of our nanotape can hold up 3.6 kilograms of mass. The palm of your hand has about 100 centimeters squared area. This means that with just one hand, you could hold up 360 kilograms of mass, which is a lot more than you weigh.
Well, if these forces are so strong, how can the gecko remove its foot when it wants to walk?
The finite pull-off force required to remove the gecko's foot from the wall depends upon the angle at which the setae on the gecko's foot pad is oriented to the surface on which it's climbing. If the angle is less than 30 degrees, pulling the foot off requires a large amount of force. However, if the gecko rotates the setae above 30 degrees, the pads peel off, allowing it to spontaneously detach itself from the wall.
Well, how many geckos were killed in the making of your gloves?
No geckos were harmed in the making of the gecko gloves. The gecko gloves are actually manufactured using a photolithography process. A catalyst is placed upon a substrate, and then carbon nanotubes are grown on that substrate using a gaseous mixture of hydrogen and carbon at high temperatures.
It's like a stencil.
The carbon nanotubes are grown in patterned clusters, which allows the individual nanotubes to behave like the spatulae, while the clusters themselves form the setae.
Well, what if the gloves get wet or dirty, or if I hang onto the wall for too long?
Gecko setae are actually extremely hydrophobic,
They don't like water.
Oh, right.
and due to an energetic disequilibrium between the gecko foot and the wall, they're also self-cleaning.
They don't like dirt.
Oh.
Plus, unlike viscoelastic tape, which are extremely time-dependent, the stickiness of the gecko adhesive doesn't reduce over time.
And you can hang out as long as you want.
Awesome.
Here, Bobby, why don't you give these gloves a try?
Cool.